In this video, we're going to talk about 4.3 Objective 6, where we calculate the 5-number summary and draw box plots. Box and whisker plots is what they're talking about there. So we're given 4 sets of data here, and we are asked to construct histograms for each set. Remember that our histograms are going to have frequency on the y-axis and our data value on the x-axis. This is automatically wrong, and that one's automatically wrong. And which one has the data at 9 would be this one. And it appears 7 times. So there we go. Construct a histogram for 7, 7, 9, 9, 9, 11, 11. So it's not these. And we have to have the data on the bottom and the frequency on the left. Now we have 888, so that happens 3 times. Then 9 happens 1 time, and then 10, 10, 10. And again, we need to have frequency on the left, and it needs to look like this, with 8 happening 3 times, and then 9 happening 1 time, and 10 happening 3 times. So there you go. And then those options can't be right. 4, 4, 4, 9, 14, 14, 14. So we have to have 3 distinct data values here, and 3, 1, and 3. There we go. So the 5 number data summary: low value, low quartile, median, upper quartile, high value, like so. Now, to show you that everything comes out that way, if I come in here and put 9 in 7 times, 1, 2, 3, 4, 5, 6, 7, and run my 1 variable statistics, which gives me my 5-number data summary, that the min, first quartile, median, third quartile, and max are all 9. So everything is just going to be sitting right there at 9, all clumped together. Let's come back in here now, and we have 7, 7, 9, 9, 9, 11, 11. And we want to run 1 variable statistics on this list. And we get that we have a min of 7, a Q1 of 7, a median of 9, an upper quartile of 11, and a high value of 11. So we should see a little bit of a box here, but the end of the box is the end of the whisker, so we don't see any whiskers on the box. We just see 7, 9, and 11. So it's going to look like that with A. Now we have the set 8, 8, 8, 9, 10, 10, 10. And we have min 8, lower quartile 8, median 9, Q3 10, high value 10. Again, it's going to be a box with no whiskers, 8, 9, 10, like so. And now we have, we're going to edit. Our next list here is going to be 4, 4, 4, 9, 14, 14, 14. Stat calc, 1 variable statistics. And we have 4, 4, 9, 14, 14. And so we have a box with no whiskers again, and it's going to go from 4 to 14. It's going to be A. Compute the standard deviation for each set. We know this is 0 because there was no deviation. I'll just go ahead and get the standard deviation for this one right now that we're on. And that was 5. This one. Come back for editing this. We'll get 8, 8, 8, 9, 10, 10, 10. And we'll get the standard deviation here was 1. And we'll get edit 7, 7, 9, 9, 9, 11, 11. And standard deviation here to the nearest tenth is 1.6. Standard deviation of a measure is a measure of how widely data values are spread across the mean. That is that looks like it got off, but in the first data set, the difference between the highest and lowest values is 0. And standard deviation is blank. Fill that in a second. That's a number 0. And in the last data set, the difference between the highest and lowest values is higher. 14 minus 4 is 10, right? Then in the other data sets, and the standard deviation is the highest. So this is actually 0.0. They wanted us to go to the nearest tenth. So let me go back up here and say that 0.0. Okay. The accompanying data sets gives the ages and years of a sample of cars in faculty parking lot and a student parking lot at the college. Complete parts A through E. We have the data set down here. Here it is. So stat edit, and I'm just going to clear this data, and I'll put faculty in L1 and looks like the faculty members are driving newer cars on average. Students, for the most part, are driving older cars. Makes sense, right? So, but there's more variation in the students. Some of them have very new cars. Some of them have very old cars, where all of the faculty members seem to have cars that are pretty much right around 5 years old. So let's go ahead and review the data here, stat calc, one variable statistics. We're going to get our mean for each of the 2 data sets for the faculty cars, mean, and then median is Q2 here, which is going to be 4, and our range is 6 minus 2 is also 4. Very interesting. Let's just go the 5-number summary while we're here. Low number is 2, low quartile is 3, median is 4, upper quartile is 5, and the high is 6. And let's see, find the standard deviation for the faculties to the nearest tenth, so 1.2. And then using the rule of thumb, which is going to be the range divided by 4. So high minus low divided by 4 means that S is about 4 divided by 4, about 1. And 1.2 was pretty close there. So now let's come back and run our one variable statistics on our second list of data for the students. And the mean is going to be 7.2, and the median is going to be 7. And the range is going to be 11 minus 2 is 9. And let's get that 5-number data summary. Here it's going to be 2, 5, 7, 10, and 11. Our exact standard deviation for the students is 3.0. And our rule of thumb for the students, I'm going to say 11 minus 2 is 9, divided by 4 is 2.25. And not a bad estimate, but we could do much better than that. So all right. Does the rule work well in each case? No. It worked really well in the first case, but not in the second case. And why not? Messed up here. I need to round this to 2.3. They actually say this does work well. I wouldn't consider 2.3 to be a good estimate of 3.0, but I guess they do. And they say that it works well because there are no high or low outliers. Based on your results, compare and discuss the two data sets in terms of their center and variation. The mean age in the faculty parking lot is lower than the mean age of the cars in the student parking lot, and the variation in the ages of the cars in the faculty lot is lower than the variation of the ages of the cars in the student parking lot. That's what we're going for. So let's just go look at that again so you can see that. So we have lower mean age and then lower standard deviation for sure with the faculty. So there we go. And the accompanying data set shows the age of 7 presidents, the first 7 presidents and 7 recent presidents of a certain country, the time of inauguration, complete parts A through E. So let's go ahead and clear these lists. And let's use the data down here. So stat, edit, it's going to be 57, 61, 57, 57, 58, 57, 61, and 58, 49, 66, 61, 43, 51, and 44. So we're going to see that there's a lot less variance in the first 7 than in the last 7 here. And we have a mean of 58.3, a median of 57, a range of 61 minus 57 is 4. Let's come down here and give the 5-number summary is going to be 57, 57, 57, 61, and 61. And then standard deviation is going to be 1.9. Rule of thumb, we're going to take our range, which is 4, divided by 4. It's 1. And now we're going to go to B. Which is based off of list 2. Right, we have 53.1. Median is 51. Range is 66 minus 43 is 23. 5-number data summary, 43, 44, 51, 61, and 66. S to the nearest 10th is 8.7. And we're going to take that 23 and divide it by 4. And we get 5.75. Then we're going to round to 5.8. Does our rule of thumb work well for the first 7 presidents? No, because the size of the data set is so small. Small differences in one of the values is more noticeable on the impact of the standard deviation. Since we're dividing by a smaller divisor, it has a huge impact. The actual standard deviation is almost twice that of the one found by the rule of thumb. See that it's almost 2, and we got a rule of thumb of 1. Same thing going on here, that we have size of the data set is too small. The actual standard deviation is about 50% greater. If we look at 6, and another 50% of that is 9, and that's almost 9. Based on your results, compare and discuss the 2 data sets in terms of center and variation. So the mean was higher for the first set, but the variance, the standard deviation, was much lower. So the mean age of the first 7 presidents was higher than the mean age of the recent 7 presidents, and the variation in the ages of the recent 7 presidents is higher. That's that one. And that's it. We'll come back next time, and we will start to talk about topics from chapter 5. So see you for the next video.